Our next speaker, or the first one of today, is DorotaC. She started camera on the Linux with Purism, and she thought it's way too difficult to do camera on the Linux. There are so many things you have to take care of: denoising, shutter lengths, feedback loops, and many, many more. And she wanted to make that easier. So she has a motivation, and now we are able to listen to it. So please have fun with the talk. Libobscura, cameras are difficult, and libobscura is the friendly camera library. Please enjoy the talk with a round of applause for DorotaC.
Yeah, as it was said, I started libobscura. I am DorotaC, and I think cameras under Linux are a bit too difficult. You might think that a camera, what is a camera? It's like a box with some optics and some light-sensitive stuff inside. So it's not really that difficult. There's a couple of components, except we made a mistake of adding computers to it, and that makes it difficult. But before I get into it, I want to tell you exactly what I mean by a camera library for Linux. And a camera library that I am making is one that is only concerned with cameras that are actually part of the computer. And the goal is to abstract them enough so that an application author can write an application that works on many different cameras without worrying too much. So for example, cameras like this webcam over here, which is pretty easy to use. You just set it and it pretty much just works. You don't have to mess with it. Or cameras like on the phone, where you can perhaps change some settings. It's more complicated, it gives you more power. But the reason why I wrote this library in 2024, I mean, the phones have been there for a decade or even more. So the reason is, Linux has not been concerned with those complicated cameras until very recently, because it started getting popular on smartphones only now. Before that, it was only USB cameras, which are really amazing in that sense that the USB protocol just makes it, you don't have to care about anything. You don't have to care about anything. Meanwhile, on phones, every camera has to be driven differently. And my story starts indeed with this phone, the Librem 5, where I was responsible, that was a couple of years ago, I was responsible to figure out the camera problem. So I have to figure out the drivers, I have to figure out the camera application that we're going to ship, I had to figure out whatever is in between. And that whatever is the libobscura, which was not present back then. So my task had to be figuring out what actually exists in the Linux space. And that's a task for the 10 times developer. So what do we have? Oh no, this is entirely unsupported. No one wrote any drivers for this. I mean, it's kind of understandable. We only just made this phone a couple months ago. But the other problem is, this doesn't have any hardware processing. So all the image processing, I would have to write myself. Well, okay, there are some attempts already, so let's try and take the user interface from here and start coding. The user interface from here, processing, I have to write myself. I have to write the support. So, oh, but there are bindings. That's okay. Take it from here, take it from there. And what happened was this camera library that I managed to do with the help of some other people. Yeah, it's actually kind of bad. It's a combination of many different things that don't really match together. And it only works on this phone, so if we ever change the hardware, we have to change the library, and no one else in the Linux ecosystem can use it. Maybe I'm not a 10 times developer. I was kind of thinking maybe it would be easier to write everything from scratch, but that didn't happen until very recently when I learned about something called Prototype Fund, where they give money to open source projects. And I'm like, yeah, it's easy to write an application. No, the idea is crazy, but I might as well just send the application and see what happens. And Prototype Fund was like, here's the money. I'm like, what? And this project is extremely ambitious. And like, why would you? Well, okay, might as well give it a good try. So what do I want a camera library to look like? My dream camera library. Oh, that went wrong. Sorry about that. Oh. Yeah, where were we? So my perfect camera library would be, I have this amazing form right here. Please fill out in capital letters. Who is the most important for the project? I have a feeling that not every open source project is really focusing on the users. Like, we are developers. We do the thing that we need, and we try to focus on our needs. But with libobscura, I wanted to change it. I wanted to make it easier for users to be able to actually use it, because otherwise, what's the point of the library? So users are the greatest priority for libobscura, and also manufacturers. So I was starting from this point that was the entire story. I was a part of the manufacturer company, and I wanted to make a Linux phone. I want Linux phones to exist. I want to make it easy to build new Linux phones. So I want to make it cheap. I want to see more of them. So manufacturers are also super important. Thankfully, those priorities do not collide. So I can take care of the users, and also maintainers are going to benefit from it. And again, documentation. I want the users to just go in and solve the problem. So tutorials, and if some problem is not clear, then maybe some detailed explanations, API reference. In documentation, I want all of the above. Contributions via mailing lists, smoke signals. I mean, I like how decentralized they are, but I'm not excited about those. So no, GitHub. I don't trust Microsoft to gatekeep my project. Goldberg. Users should focus on building ideas, solving puzzles, remembering. No. A user comes here to use my library with a concrete problem. They want to solve something here already. I should not give them more problems to solve. I should make it as easy as possible. Of course, you can't avoid entirely adding complexity to your users, because, yeah, libraries are complicated on their own. Programming is complicated. Mistakes, that gets us to mistakes. Mistakes should not get segfaults. I'm going to become a little preachy about it, because segfaults don't tell you what happened wrong. They don't even tell you reliably where it happened wrong. It might be that you broke some property a lot earlier, and then it comes bite you a lot in a completely different place of code. The only worst thing is quietly ignoring errors. And like, we've had automatic memory management for the past 60 years. As an industry, we had the time to learn from it. So if you impose manual memory management on your users, I'm judging you. So ideal error messages are those who tell you what went wrong. And even better, the error message tells you what to do to fix it. That will be perfect. And that brings us to the choice of language. C and C++, they don't get the memory management story right. Python might be a bit too slow to implement all the processing, so Rust is like the least bad option of the mainstream options. License, proprietary, of course, no, that's a joke. MIT, I don't like freeloaders, so if you contribute to libobscura, also give back the contribution. LGPL. Governance. I want to have like the creative direction, at least in the beginning, but I want maintainers to come over and take it from me. I'm not going to stay at every project forever, probably. So it's nice to have a healthy community. Supported devices, only video for Linux devices. So I don't think IP count there, but everything else, like phones, Raspberry Pi, I'm open to it. And I think that should be really maybe even the focus. What's more important, covering every need or staying simple? I think we have like this idea of or like the need to generalize things. But if we stay simple and try to spread a little bit from there, I think the results might be better because we just don't try to put everything in our heads at the same time. So let's stay simple and see where that leads. And now the big question, how will you achieve all of this? Yeah, I have identified a couple of sources of complexity which are on the slides, and now I have to find the right slide. Yeah, presentation mode, thank you. And the complexity sources come from different, well, they're different, they come from different places. One of the sources is the same regardless of how you take the picture. It's just the complexity of taking the picture. So let's go through that. I introduce to you my assistant. Hello. And right. And let's take a picture. So what do I do when I take a picture? I set the aperture and maybe some focus and click. What happens here? Some light goes in from there and goes through the optics and hits the film, in case of film camera. And that happens, what happens there is a conversion from the spectrum of light to like 3 different chemicals which respond to different kinds of light, different spectra of light. Yeah. And now we have this on film. This is like the not avoidable thing. When you have a digital camera, the sensor also has like 3 different sensitivities to different colors. So this is like the first step of conversion between like the actual light to the colors. And then we have the film, so we go to the darkroom. And in the darkroom, thank you. In the darkroom, we project the film onto some paper, and we end up with a picture. But what happens here? The film has some photosensitive stuff, like 3 different chemicals that we exposed before, but the paper has a different set of chemicals. So those are not the same. And what happens here? I think they are like very carefully selected so that they almost match, but I don't think they match exactly. And that means there's a color conversion going on between 3 different kinds of red, green, and blue. And this is also what is happening when you take a picture with a digital camera like this one, because the sensor sensitivity, or the sensor 3 different colors, they are different than the 3 different colors that are being displayed. Those are like pigments or something, and this is light. Those are not the same. So there is an actual color conversion again. And yeah, what kind of a picture did I get? Let's take a look. Oh no, it's blurred. Let's change the focus a little bit closer. Click. It's overexposed. No. Okay, let's change the shutter time. A little bit, click. And there you go. The photo is perfect. But what did I just do? I repeated the same sequence, almost the same, a couple of times. I created a feedback loop because first I evaluated the brightness and the sharpness of the pictures, and then I repeated the same sequence by changing the parameters of taking the picture until I was happy with it. So I performed like a looped operation until I was happy with the result. And yeah, This is something I'm going to have to implement in libobscura, because not every camera actually has a built-in feedback loop. Yeah, but it's easy. A feedback loop? Yeah, come on. Oh. So you also know about the Bayer array. Of course I know about Bayer array. It's the thing where the sensor on the camera is actually not capturing every color on every pixel. There are gaps of colors, and you have to fill in those gaps. You have to interpolate that. Nice. So you also know about the color conversions that you're going to have to do. Oh yeah, so the sensor that's on the camera doesn't perceive the same colors as the human eye does. And it means that, oh no, you have to go into color theory and find the color matching function with negative colors, negative light. Oh, you know everything about that. So, and remember, every sensor is slightly different. But you're also going to know everything about dead pixel detection, downscaling, upscaling, denoising, tone mapping, YUV output, dark frame subtraction, lens shading, chromatic aberration, lens distortion, focus stacking. What did I get myself into? Yeah, so that was the easy part. Those algorithms are all well known, so you just have to look the right paper and you can implement it easy. The difficult part is we have no algorithm that definitely works for creating software. And one part of it is the abstraction. So if you take a look at the camera, well, yeah, this phone has actually 2 cameras. And the purpose of the library is to abstract and expose the details of the configuration in such a way that you can write an application once and it always does the right thing. So we have to make sure that the camera is always selected correctly, and that one camera has a flash and one has fixed focus and the other doesn't. And there are phones which have 3 cameras on one side, and this laptop has also an infrared camera. So let me show you how it looks like from the Linux driver side. This is the pipeline for the USB camera. The pictures go from the top here, from the sensor, all the way down to, from the sensor, no, wait, that didn't work. From the sensor here all the way down to the video device, and there's another video device which is actually connected to this one, but you don't see it on this diagram. So you have a different camera, and this is actually the one on this laptop. There is 1, 2, 3 sensors, 1, 2, 3, 4 camera devices, but this one doesn't have any sensor. And what is this? This is actually the motor that controls the focus. So you have to also take care of that. And this one, this doesn't have any sensors. You feed the pictures into those to camera devices, and you get pictures out from different camera devices. So this is entirely a picture processing pipeline. And let's take a look at this monster. Yeah. You can connect up to 4 cameras in any way you want, and a good library should abstract all of this. Right, including the information that is actually not visible on this diagram, because there's a bunch. So let's go back to the presentation. Oh, okay. And there is the last category, which is the actual programming, the abstraction of the video for Linux, the choice of the language, the choice of the architecture, the way that we handle buffers, for example. Those things can only be figured out by more coding. And this is what I've been doing for the past couple of months. And the result is libobscura demo. As you can see, I already ran it, It's going to be running on this camera because I've been busy preparing the presentation instead of adding support for this one. So there we go. A moment for initialization, and we have something. So let's mess with this. Change the contrast. Yeah, maybe saturation. That looks crazy. So what you're seeing is the support for controls. Let's crash it, maybe. No, it doesn't crash anymore. Nice. Yeah, it does. So this shows the support for controls. This also shows the GPU processing that I implemented. It converts the YUV output into RGB because our displays typically show RGB colors, and cameras, for some reason, produce YUV colors. Color conversion, as I mentioned before. That's where we are with libobscura right now. It only supports, thank you. Right now, it only supports USB cameras, and it has some examples and documentation, but I'm under no impression that it's good. I tried my best, but I'm not the best person to write documentation, but I'm trying hard. The architecture is actually split into two pieces with a lot of supporting libraries. VD is the actual camera library. It actually manages everything about video for Linux. And CrispyCam is the one which contains the GPU processing algorithms. So what do we want next? I want to add support for the Librem 5, which is my only smartphone. Also for this laptop, because I think it's cool to have a laptop with a nice camera. Better documentations, of course. And a scripting engine. OK, this is a funny one. It's kind of an experiment, again, within an experiment. What kind of a scripting engine? What do you need to script a camera library for? And like, what kind of a language would I use? Any guesses? Lua, Python? No, that's easy. I wanted to try with Prolog. And why did I try with Prolog? See, so that's the thing. I want everything to be declarative. I really like declarative things. So remember all those different configurations of video for Linux things? Yeah, this one. I want to not have to write all those algorithms myself. I want the device manufacturer or like the distro maintainer maybe to describe what each of those devices does, each of those nodes over here does. And I also want, on the other side, to describe what kind of an output I want. So in this case, I'm just going to go a little bit deeper. And if you see this device right here, it has a certain resolution, it has a certain color properties, and those nodes might change it in some way. It might, I don't know, for example, rescale it or something, and then those devices are also with their own properties, different resolutions. Maybe they don't support everything that is happening on the top. I want all this complexity, finding the right pipeline from the top to the bottom, to be automated by language which is kind of easy to change. Maybe I want to add some metadata. I don't want to write everything like this in Rust. Rust was not meant for this. I want to query what are my options, right? And this is already implemented in selecting the resolution for a single camera. It's a very basic concept. I don't know, maybe it works, maybe it doesn't. And yes, that would be the end of the presentation. But I wanted to make note that this is just the tip of the iceberg, and there were many people involved in this. There were people who provided all the libraries that I forked or I contributed to. There were people who gave me feedback. There were people who wanted to test their cameras. If you want to test the cameras, if you want to contribute to the documentation, if you want to report bugs, and if you want to help me find bugs again, like the one that I just found today, or maybe you're arrogant enough to actually give it a try and write some more interesting algorithms, yeah, please talk to me. Thank you.
Thank you very much. It was a really interesting talk. You now have the chance to go to the microphones and ask questions. Do we have questions from the internet?
No questions from the internet.
Okay, then we go to this microphone here in front, please.
Hi, thanks for taking on the task to try to implement this from scratch. My question is, why should I prefer this over something like video capture API in OpenCV?